One. Hello there, all. This is Mark Overholzer with the CoCo Nation, and the Glenside Computer Club and the CoCo Nation are doing a virtual fest. And so I have our second segment here. I have with us Julian Brown from the UK, United Kingdom, England, and he makes stuff for the Dragon, including Dragon 32 reproduction board and some other cool stuff. And also, this relates to the CoCo because, hey, the Dragon is our cousin. So he's going to show you what he's got, and you'll know what he has available. Take it away, Julian.
Okay. Hello, everyone. For those that aren't familiar with me, which is most of you, I'm a software engineer by profession. I've been doing that for a very long time, having been an electronic engineer reject, amongst other things. And I have a story to. I can't even say it. I'm getting tongue-tied. I'll try again. And I have a story to tell. Always a good start. Get yourself tongue-tied. Anyway, so what I'm going to do is I'm going to tell a story about how this came to be and the pitfalls, the nightmares along the way of recreating, designing, and improving the aging Dragon 32, your CoCo cousin. So most of this is going to be by slides. I'll cut in and out. And I'll try not to mute myself or disconnect myself. I am renowned for this. So if everyone is sitting comfortably and everyone is here, I shall get started, assuming I can find my share screen button again. So, how to cook a dragon. And the best place to start with this is 40 years ago when I got my Dragon 32. My first computer, it's inspired me for a long time. And I used them for years, put them away, completely forgot about them, and decided, courtesy of lockdown, to try and get back into this. I say lockdown. This is gone on longer than that, but basically, I've neglected my electrical engineering, or electronic engineering, perhaps would be a better description. If we talk about soldering irons, I'm dangerous to equipment, not myself. I've never set myself on fire, either burn my fingers or my hair. So thinking I'm still in my teens and I know what I'm doing, I tried to fix some old computers that I managed to pick up cheap on the internet. It didn't go well. First lesson, don't use an unregulated soldering iron. It will kill anything it touches. So ditch that, get yourself a nice modern temperature controlled soldering iron and test it again. With some success. Did I fix those old computers? No, I didn't. But I didn't destroy them, which was an improvement. So I thought, okay, well, I know what I'm doing with the Dragon. I've spent more time with that hardware than anything else. Why don't I get one of those and try fixing that? I could have pulled my own out of the loft. I could have seen if they were broken. I could have attempted to fix those, but they're prized possessions. I've had them a very long time, over 40 years, and I don't want to break them. So cheap eBay purchase it was. And I bought a spares and repairs, half expecting it to work, which it didn't. What I got was garbage, on the screen, that is, on the computer, which was a bit disappointing. But after all, this is what it's all about. So I thought I can fix this. So I pulled it open, looked inside. Everything seems to be okay. And with a bit of playing around, probing it about with a cheap bit scope that I purchased a few years earlier, I found basically it had a broken trace, and just a few bits of information weren't getting to the VDG, and that's an easy fix. So I bodged it. I got it working. Success. For about 20 minutes, at which point the DRAM cooked itself. And all I got was garbage. Now, I could have given up. I could have gone and got another one, but determined to fix this, I went away and looked up, how do you replace the DRAM? How do you put something more reliable in there? Because the last thing I want to do is go and spend more money on 4116 chips that are as likely to go pop before I put them in the board as actually fix it. So how do you stick 4164s in instead? Okay, you can buy little shim boards that convert them, or you can do the unthinkable and bend pins out of the way or break them, which seems sacrilegious. So I thought, you know what? I can do this. I can make my own PCBs, and I can create a single board that does all of the memory chips in one go, and it just simplifies it because you can just plug it all in one go. You don't have to worry about spacing. It's all done. So, thinking I'm the next electronic Jesus, I went ahead, started using KiCad, or KiCad as they call it these days. I'm not sure which one it is. I designed my own PCB, and I went away, I ordered it, and some weeks later it turns up, and I spend far too long soldering, figuring out how on earth you squeeze basically a socket on both sides of the board at the same time in the same space. I didn't think that through, but I managed it, and I managed to do it without bridging anything. Did it work? No. So I went away and I did it again. And a few weeks later, with my improved board, I tried again. Did it work? No. As it happens, for all my efforts, the DRAM wasn't the problem. It was actually a ROM. But I was only to find that out a lot later. But never mind. What this did was set me on a trajectory. And in essence, the path to recreating the Dragon 32 pretty much from scratch. I say from scratch, that's unfair. I cheated. I used some existing schema. But the schemas weren't very good. They were dubious, far better than they had been years ago when they were first scanned. Someone spent some time refining them using various image processing to make it more legible. But fundamentally, they weren't particularly useful. They did help me with working out where I had a missing trace on my board, granted, but not so much for actually going away and doing this again. I transcribed those schema into KiCad, and being a software engineer and always looking to iterate early and to test everything I could, I went away and I ordered a PCB, or a whole set of them, far earlier than I should have done. But it was good to actually test and make sure it fit in the board and I had all the dimensions correct, which I did, thankfully. In fact, the one true success of that first iteration was it fits. Result. Now, I'd also decided to change my PCB supplier. Certain companies like to advertise an awful lot on the internet, various YouTube streams, and this is fantastic, but they're not the cheapest. They're also not necessarily the quickest, but everybody knows who they are. having done some shopping around, I found far cheaper ways to get PCBs. If I hadn't, this story probably would have been very short because the cost of producing these boards is not on the cheap side. They're just that little bit too big because anything over 10 by 10 centimeters, that is, yeah, not good. But there you go. So I went away. What you can't see, and I will just come off sharing my screen, is I have a stack here of boards. This is the offending board that actually caused me all that trouble. And I've kept this on the basis that one day I will actually fix this. I will make it work as intended. It doesn't, but that was the plan. This was my first attempt. It's pretty neat with the light shining through from the back. It looks good. It's got all the holes in all the right places. It has all the components on the board. It just doesn't have all the traces because, like I said, software engineer, iterate early, test, and improve. I'm going to get back to the slides. I'm sorry. The thing is, you keep going. You don't stop. You keep trying to improve this. And so I did. If it'll move to the next slide, there you go. Thing is, at this point, having shared my progress so far on the Dragon 32 Facebook forum, I got some good input on things that need to be changed, things that can be improved, and picked up on some small tweaks that have gone before, courtesy of the likes of Sixie and his Dragon 64 reproduction. So I incorporated those. Use 6-pin DIN for joysticks, for instance, so you can have 2 5 buttons. You know, it's been done before at the factory, just not on the Dragon 32. Put in some extra jumpers so you can bypass the inverter on the parallel port, so you can actually treat it exactly the same as the bit bang serial port on a CoCo, which is great for things like dry wire. And incorporate the necessary wiring so that you can use those 64K chips directly on the board without having to cut traces. All you need to do is set the jumper. What could go wrong? Well, the answer is quite a lot. The next board I got actually looked great. The blue one there, it looked really, really good. I tested it and the CPU runs. I wasn't getting any video output, but I wasn't really trying at this point. But the CPU runs, which means the PIA is working. The ROMs are being read. The memory's good. Using 4164s, I might add. So I only need 5 volts. And all was good. And I was thinking, you know what, I did it. It only took 2 attempts. Which would be nice if that was true, but it's not. Because the thing is that when you read the schematics, it's really, really easy to get things mixed up. And I really mixed them up because it's really important that you get the power pins in the right order. Because when you plug in that power board, if you got it wrong, bad things happen. And I actually got them wrong. As it happens, it wasn't the 12 volt I got in the wrong place. It was the -5 and +5. So you can imagine what happened when I plugged it into the real power supply and switched it on. And there's not a lot left of that one. Lots of magic smoke came out. Chips do not like getting -5 volts to the +5. Fortunately, It was 4164 RAM in there, and I only lost half of it. I didn't kill the CPU. I didn't kill the PIAs. They all survived. The 74LS chips, not so much. They were actually the big victims in that one. But not to be deterred. I fixed it. I went away. I ordered another one, and got the pins in the right order. Great. Now, that would be absolutely fantastic. And that would be the end of the story, except that it didn't work. In fact, the first thing I did was check for shorts, and my multimeter just went beep a lot. And it turns out that basically I'd forgotten to refill the ground plane before ordering. And all of my traces just went through the ground plane because I'd moved them around, thinking, you know, I know what I'm doing. I know how this works, and this is easy. But yeah, let's not go there any further. So let's do this again. The next board. So we're on revision 1.6 now. The green one at the top of the screen there. This was promising. We fixed all of the things that could possibly need fixing. No, still not good. It's getting there. It's getting better. The issues are getting fewer and fewer. But whilst I managed to fix the ground plane issue, let's face it, I just refilled the ground plane, reordered. It didn't do quite what I wanted, but we get to the 1.7 board there, and we actually have a working computer. I have a working Dragon 32 created by my own hands, assembled and tested by me. It's taken some doing, and I'm finally getting there. However, there's a problem. It works great in monochrome, not so much in color. In fact, if you put the modulator chip in, whilst you can see what's on the screen, it's not pretty. It's ugly. I mean, really ugly. It makes your eyes hurt because the colors are seriously messed up. It turns out that, in my wisdom, I'd managed to get two traces mixed up, and they just happened to be the PAL phase lines that go through an op amp. And if this was NTSC and we had this, you probably wouldn't notice. It might get a bit dirty, but PAL really, really doesn't like it. But never mind. So if we accelerate through to this, I'm positive I've got it now. I have sorted out everything on this board. And I don't need to worry anymore because fixing that, which is basically uncrossing two wires, and incidentally, I blame the schematics for it because they actually reverse two pins on the schematics just for convenience. And of course, when I transcribed them, I just copied the standard symbol across and didn't actually pay attention to pin numbers because you can't read them on the schematics. I just went, yeah, that one goes there, that one goes there, jobs are good, and off you go. No, they actually use a bit of artistic license, and
The CoCo
less said
ones
the
have
better.
the CoCo ones have the same issue. People have gone through them, like Rocky Hill, Pedro Pena doing the CoCo
Yep.
2 and 3 is like, these are wrong. Other
Yeah,
people have
and
too.
you know
So.
what? I actually found quite a bit on the schematics that needed attention. It's not so much they were wrong because the factory schematics were right, but only if you use, for instance, the factory BOM, which isn't included with the schematics. So some of the parts have been changed. And of course, just to make things awkward, Dragon Data created 3 different sets of schematics for their early boards, depending on who's making them, what parts are being used, which led to some confusion, not least of all because component rating, capacitors and resistors changed depending on which one you're talking about. They all broadly worked, and frankly, for most of it, with the exception of a few components, actually, it's not that critical. As long as you're in the ballpark, you're not going to go too far wrong. However, some of them really are important you get it right. And, you know, there's various stories in there. I can keep going on this for ages, but there are various bits in there where you can get this so wrong just by blindly following the schematics. And I did. I confess, you know, I trusted them, and it took a long time before I realized that that trust was misplaced. And I don't want to blame those engineers because they were doing their job. And let's face it, they managed to get an awful lot of these computers out there. I mean, at one point, it was the best-selling computer in the UK by some margin. And that wasn't just one short period. It happened repeatedly as the market wobbled backwards and forth. But ultimately, you know, as the story goes, they ran out of supplies and couldn't compete. They couldn't make enough of them at the right time. How they managed to get any of them out, given the design issues, I don't know, but never mind. Anyway, so on to revision 2. I've got this. I have this sussed. So I ordered revision 2 thinking, right, this is it. This is the one that's going to solve all the problems, and I can draw a line under this. It's done. And the answer to that is, yeah, it's done. It's just not done, because me being me, I had to make some tweaks. I had to make some other improvements because I wasn't quite happy with some of the traces, their proximity to other things. Some of the spacing on the board, although the chips are all in exactly the same place as they are on the original, the other components around it, there's a little bit of artistic license in there. I've used a different relay. I moved a couple of components around. It's all identifiably in the same place, but if you were to get the ruler out or do a side-by-side comparison, you'll spot the differences. Nonetheless, what could go wrong? Well, the answer is Git. To this point, I've been doing all of this using Git for version control. So if I do have to go back, if I make a change and I want to reverse it, I've got a history. I'm a software engineer. I use this all the time. It's really, really good. Unfortunately, what it's not good with is KiCad. Despite the fact KiCad uses a text format to describe all of the content in the schematics and on the PCBs, it doesn't do it gracefully. So one small change on the board can result in a whole domino chain of effect in terms of how the file is organized, and it shuffles it. And it so happened that I was using 3 different computers at this point to do the work, depending on where I was sat, what time of day it was. Am I on my lunch break? Am I doing this from the office whilst I consume my meager lunchtime meals? The end result was I did a Git merge and it complained. It said, nope, you've got something wrong here. In the end, I had to make a guess as to which bits are right because KiCad doesn't make it obvious. And I ordered it, built it, tested it, and was really confused when I got exactly the same error as I got on a previous board. Really messed up video once you put the modulator in. Really weird. In fact, the amazing bit was you could take the op amp out and it actually made the video better. You got color, Just so you know, there's a feedback loop between the output of the op amp and the input. If you take the op amp out, that feedback becomes a feed, and it pumps the color through, and it actually looks pretty good. It's a bit washed out because the levels are all wrong, but it works. And I scratched my head. I went, I fixed this. I know it works. I've seen it. And it was only with a sorry heart and a sore head that I went through the schematics and went, man, you are an idiot. You fixed this and you unfixed it in that order. Again, it's trivial to fix, but a very painful lesson that. Go on.
Ron, who's on the call here with us, asked the question, and Simon Jonasson, who's also with us here, asks, so how many pounds did you spend trying to get this right? Are you going to give that at the end?
I'll give that at the end. I actually kept a spreadsheet of this. I added it up.
The cost of your futility. I mean, no. Okay.
Well, no, that's a really great description of it. But the amazing bit was it wasn't as much as it could have been. It was half of what it could have been if I hadn't changed my fabricators. Yeah.
Okay. Continue.
But it's still painful. Still painful because the amazing bit on this is I've ran out of sockets. You know, just regular dip sockets, 14 pin, 16 pin, 20 pin, occasional 18 pin. I'm sure that when I started this, I had tubes upon tubes of them. I had hundreds. At this point, I'm going, where's it all gone? And scarily, I can't buy any because the mainstream suppliers don't have any.
Right.
They've run out. So either I created a worldwide or at least a national shortage of dip sockets, or I'm not alone. And there's a lot of people out there doing the same sort of thing, building their own computers. This is lockdown after all. Although, to be fair, we're not in lockdown anymore. This is quite recent. This is a year ago at this point.
Frederick Sigard, who's also on here, he's building his own single board computer, I believe, with the 6809. He was asking, what was the fixed positive feedback at the op amp versus negative feedback? Or you don't lose your story.
So basically, I had the wires crossed again. So I had the plus minus input, not the voltage, but the signal, because it's differentiating. I can't even say this. Differential op amp. So yeah, it really helps if you get those the right way around. I have I'll come off, stop sharing for a moment, so you can get a close up with it. So get the lighting right. The op amp there, you'll see, has two bodge wires hanging off of it. That is an op amp in a socket with the pins bent, so I can actually pull this in and out without breaking the bodge wires. This has seen a lot of use. It took a few attempts to actually get this to work as intended, but it did its job. It's migrated from or between boards, and it has got me out of a real fix. So I ordered another board. I can't call it Rev 2 anymore. This is Rev 2.1. The red board. Ordered that in. It arrived some weeks later. In fact, there was a delay getting it. I was getting a bit frustrated and worried that I'm not going to get this board, especially when it's just like I am so close. I am so close to getting this. When it arrived, put it all together. It worked. First time, no problems. It just worked. I think that is called success. It's done, as in done. This works. All the features are great. And the best bit is that you just plug 4164s in. You actually save a bit on the BOM because there's a little bit less to look at for using 4164s versus 4116s. And, success. As I said, I have achieved what I set out to do. And at this point, I actually offered these to the Dragon community. And I sent a few of these red boards off to willing volunteers. So I believe Todd, one of our regulars, has one. Noel's Retro Channel got one. More Fun Making It got one. And I sent one out to, I'm trying to think whether it was Sixie or Mike actually got one as well, as a thank you for contributions and assistance along the way. And I ordered more, another 20 boards, I think, and I have 3 left, if anybody is interested, by the way. The thing is, why stop there? Having achieved so much, why stop there? And there's more you can do. Now, Stuart Orchard, some time ago, had recreated a 256K banker board. 256K chips fit straight into those sockets. All you need is an extra wire to fix the extra address pin. Yep, I can squeeze that in. Better still, I want to make this board more usable. So I can either do an NTSC version and a PAL version, or I can just take those off the board. I can make them separate and you just plug them in. So if you look at the blue board there, you'll see it actually is missing an essential chip, the VDG 6847. In its place, it has an extra PIA. So I can actually use that extra PIA to provide addressing to the video board. I can start doing extra tricks. The one in mind was actually to create an external programmable character generator. So you can start pulling off tricks that are familiar to most other 8-bit computer owners. And what I really wanted to do was get the 6847 to do things it was never meant to do. Or at least not if you played it by the book. And that meant you need direct addressing on things like the graphic modes, the color select, the internal, external, the inverse, and the semi-graphic select line. I think I was getting a bit over ambitious at this point, but it seemed like a good idea at the time. The board there is tested, it works, but not with 256K because I omitted a line, and the extra chip that I used to disambiguate the PIA memory address space, I used the wrong address lines. So A0 and A1 are your register select as normal, and I should have used 2, 3, and 4. Somehow I managed to use 1, 2, and 3. So I had to hardwire that one. But otherwise, it's great. It does everything it was meant to do if you added some board wires and you short circuit the extra PIA select. And this has been a great boon because I'm suddenly in a position where I can experiment with the VDG. I can do all sorts of things. But first off, let's make sure it works. NTSC. The NTSC board, as many will have heard on a regular CoCo Nation weekly show, just works. It hasn't got the color burst control on it, so it's a bit iffy getting artifacts in high res. Sometimes it works, most of the time it doesn't. But that's no big deal. For a lot of people, it was like, don't know. But I wanted to improve it because the NTSC quality was shocking.
Bad.
Green and black don't go well together in NTSC. I know you guys out there, you already know this, but I've never had any NTSC equipment to play with. This was the first time I got to try it out, and yeah, that's not good. So I built an improved version of that. It's actually an little 4-layer board instead of a 2-layer board that I plug in, and it's cracking. It's really good. I still need to do the extra color burst circuitry on there and make it selectable in some way, but I'm happy with that. I'm really happy with that. The power board has been a problem child. I thought I'd do 2 things at once, which is always a really bad idea. So I started switching the board over to use SMD components because the board was just a little bit too big. Just a tiny little bit too big. And the easy to obtain SMD stuff is not LS. It's HCT. And I've created timing problems. And I suspect the timing problems have always been there, even with the LS stuff, but the response times of the chips weren't the same. So you didn't see it. And the issue with this is it runs PAL, but it runs at about 55, 56 hertz frame rate because it doesn't put enough extra lines in. It takes the right amount of time to generate the lines, but the actual number of lines it generates is wrong. And I have scratched my head on this radio. So I've actually reversed the move to using SMD components, at least for the LS chips. And I'm waiting on those to turn up. They should be here any day now. And we get to try that again. But whilst doing all of this, sorry, go on. Another question, please interrupt.
Frederick here had a question. They're being polite and not interrupting you, which is very nice.
No, interrupt. Everybody else does. Anyway, never mind.
Okay, Frederick, you asked about static RAM. Are you talking about for the main memory or static RAM for what?
Yeah, because I think you're using dynamic RAM right now.
Yeah.
And why not swap to static so that way you don't have any issues with refresh timings?
Yeah. And funnily enough, the next stage in this story is exactly that. So last year, Kieran, end of last year, was it? Or beginning of this year, Kieran came up with his SAM X4.
He's in the chat, so he
is in the chat. I can see his comments flying past on my monitor screen. And it opened up all sorts of possibilities. So I chat with Kieran. I'm not going to say all the time, but we chat. I chat with John, who makes the PSU boards.
Whitworth.
John Whitworth, yeah. So Dragon Plus Electronics. We bounce ideas around from time to time. We talk about things. So the SAM X4 comes along, and I'm going, oh my word, this just makes my life so much easier. If you go back and you look at my Git repository for this project, because incidentally, this is all open source. Anybody who wants to dive in, hey, go ahead. I don't care.
I'll get all those links posted for everybody too after the fact.
Yeah. Cool.
Hey, Julian, I just wanted to interject here in case people haven't been paying attention. Most people do, but might as well. So 60, Kieran here has the Dragon 64 board that he's worked on. And then Rocky Hill, who's also in the online chat, he has actually did the same thing with the CoCo 2 board and the CoCo 3 board. So between the three of you, the 4 major
we've got the color computer market covered.
Yeah, pretty well covered. So if you want to build your own because you have a bad circuit board, but you have all the components, get a hold of one of these people because they got the stuff.
Yeah. So Rocky Hill, Pedro, and Kieran are my inspiration for this. They'd pretty much done all of these things by the time I really got started, and if it hadn't been for them, I probably never would have finished because I've started. I want to achieve the same closure on it. Well, I'm not going to say success, but the closure on it of actually getting this finished and out there. And moreover, the frustration of why isn't mine working? Get that out of the way. So just following on from Frederick's question about the SRAM. Yes, the thing with the SAM-X4 is it means I don't have to do the whole RAS-CAS generation, multiplex the signals, then demultiplex them just so I can use SRAM. I can cut all of that out and just use all the address lines I need. So this is for 256K. So funnily enough, I've got 18 address lines. If I want more, if I want to boost this up to a bigger RAM capacity, and I am tempted, then it's just a case of squeezing those traces in somewhere. The board itself, pretty much everything on here is SMD, but you'll notice in terms of the SMD chips on here, there's 6 that are related to the original functionality, and 7, which is the replacement of the SAM. The need to separate out data in and data out to make everything else behave as it should, and some, I'm trying to remember, I put some latches in there. There's also an issue with voltage level, but that's a story for another day. Well, I say another day, another slide. But I've got loads of empty space on here, and why not use it? So why not put on the UART chip that the Dragon 64 uses, so you can have proper dedicated serial, and ditch those old mask ROMs, and just use a modern EEPROM. And instead of having shim boards like I've been using, just put a big board on there, PLCC format, and you've got as much ROM space as you want, and you can switch between them. And better still, you can page them, because much like the Dragon 64, use the POA to control the paging. You only need 1 bit to switch between 2 ROM images and some jumpers to say, you know, which group of images do you want, and it basically behaves like a Dragon 64, but it's a Dragon 32 if you want it to be. You have total control over this, because you own, or can own, with the right VHDL, how that SAM behaves and how the address space is used in upper memory, which is convenient. It saves on an awful lot of chips, and it generates a lot of empty space. So I went a step further, and I've planted the footprints for 2 AY3 8910 style sound generators on the board. They're emulated. They're not original chips because they don't make those either. In fact, one of the things about this board is pretty much everything on here is current. There should be no problems with suppliers with these components. The UART, I think we need a better choice. But fundamentally, all of this is modern. There's nothing old on here. The video cards, obviously they use a 6847. But as hard to find chips go, it's not particularly troublesome. But I am painfully aware that actually that's something that needs fixing. So whilst all of this has been going on, the observant amongst you will also have realized that I've been doing other things as well. So if I skip ahead just a little bit more, I have other projects related to this. So reproducing the keyboard so that you can use something that actually feels half decent, to the point where, for those that have tried it, these 2 keyboards, one's using Cherry MX brown switches, one's using white, are pretty much the best keyboards that felt on a Dragon. You know, they really do feel great. They type great, And I'd like to say it's a great success. The problem with it is the keycap. The availability of suitable keycaps with the right icons on them is limited. You can get away, obviously, with using just regular PC keys, but you're gonna fall in that horrible trap of the things like the parentheses being on the wrong keys. So you need them on 8 and 9, not on 9 and 0, and various other minor differences.
There.
Frederick's
I was thinking, yeah, raising my hand. I was thinking of doing my own keyboard. Actually, I did the PCB for it yet, but I was going to have them to source the caps, the keycaps at WASD and have them design them myself, the layout with all the correct characters that I wanted. That's a bit expensive, and they're not double shot, of course. They're printed, but at least you get to have the keycaps with the right symbols on them.
My plan's the same. The difficulty is the cost. What became really apparent last year when all of this was shown off at the Dragon meetup is great, but no one wants to pay £100 for a replacement keyboard for a Dragon. As things potentially get cheaper, maybe that becomes more attractive. But the flip side of this is, if you do like your classic 8-bit computer, you use it a lot, I cannot express just how much of a difference it makes to what it's like to type on. The advancement in key switch technology between the 80s and now is astounding. It really, really does make a difference, and you get to choose. You know, the variation in the spring tension, travel, whether it clicks, whether it doesn't, you know, all of those things just makes such a difference to getting the keyboard you want. And there's whole industry out there. So WSD keys, you know, obviously well on that tide and taking advantage of it to the point where actually a lot of the time they won't accept orders because they're just swamped. Their backlog is immense. But it's definitely on the list. The only reason I haven't actually gone down there, apart from the fact that there's this whole matter of making the Dragon boards work, is that what I really wanted to do was print on the side of them as well, on the front face.
Did you not like the Dragon?
They can't do it. Did I not like?
Did you not like the Dragon 32 keyboard? I understood
the Dragon 32 keyboard, the high-tech one. When I had it, was so much better than all of the other computers my friends had, except maybe the BBC ones.
But that was then.
That was then. I had a Dragon 64. I still got it, and it came with a high-tech keyboard. I never got to try the Alps version until middle of last year, when I managed to pick up a Dragon 64 in a sorry state. And I tried it, and I went, you know what? I can see why people like them, but what I cannot stand is the ringing, because they're on a metal frame and they click every time. It's like someone ringing a bell with every single key press. It got annoying really fast, to the point where I actually prefer the high-tech keyboard over the Alps one. Obviously, the best ground is obviously my new keyboard, not the not the old ones. But you know, there's scope there. So it does other things. The black board at the top is actually set up to operate as a USB device. I can plug it into my PC. So if I want to use X-Roll, I get to use a real keyboard, not a PC one. The keys are all in the right places. I don't have to go hunting for, you know, where is it supposed to be, which is so nice. I actually created a key map for Windows, so I can switch between them. I don't recommend using it as a daily driver on a Windows PC, at least, because you haven't got enough keys. You will get stuck. But you also notice I've put 2 extra keys on there. because the original 8U wide space bars are completely unobtainable. If you want those to fit modern key switches, you're going to be 3D printing your own. I don't have a 3D printer. This has cost me far too much money as it is. Actually, just getting a 3D printer so I can print an 8U spacebar is just too much. I can't go there. But never mind. I also played around with the floppy drive controller, the original Dragon DOS drive controller, recreated it. It didn't work first time. The pulse width on one of the control signals is half what it should be, but that's just potentiometers and capacitors. It needs attention, but it works. It does work, as in the logic. All the signals are there. They're just not timed quite right. I also created a GoTech board so I can plug it straight in and have a vertically integrated device. So you don't have the cartridge cable and the drive. You can actually just compress this all into one small space. But that was a whim. People have done it before. They've done it far better. The Dragon MMC, the CoCo SDC, effectively do exactly that. I don't need to reinvent the wheel. Although it has to be said, one of my friends has actually done exactly that. He posted the images of it working yesterday. I don't have them to hand. It's a bit chunky. It's nearly twice the size of my board, and it's stacked, so that the GoTech actually sits on top of it rather than on the end of it. And he's managed to put all the controls on there, the display. What you're going to do with it, I don't know. It doesn't fit in the cartridge port, and there's no good putting it inside the case. So it is, as an experiment, it's great, and it's definitely the direction I was going. But practical use is probably close to zero. But it's fun. This is why we do these things. You innovate, you experiment. Sometimes you get it wrong, as I keep doing with these. So I mentioned about the 6847. Again, inspired by 60. Let's replace it. Let's ditch it. I was going to fit or integrate John's Super VGA board into a single video card for these Dragon 32s, and I started doing it. I considered putting RGB to HDMI in there as well, so you could have the best of all worlds. It all fits. It's just, ouch, the components start getting small, and it gets expensive, really expensive. But with the SAM-X4, I was like, you know what, I can do this with a CPLD. Why do I need to generate the Luma Chroma? You don't. Just output analog RGB. How hard can it be? I actually sat down. I've written all the Verilog for programming FPGA to do this. The difficulty is my FPGA dev board is great, but you've got to fit all of the wires between this and the dev board. You've got to persuade the compilation software that actually you do know what you're talking about when you say, I want to use these pins for these inputs, because it resists hard. It can sit there and complain, it's going to make it slow. I don't care. I only have to run at 4 megahertz, not 400. Never mind.
Tools optimized for gigahertz, not megahertz.
Absolutely. And obviously, and this is the hard part, is these FPGAs, they're not 5-volt tolerant. And that's actually the biggest issue. The board there, those 5 chips on the board, other than obviously the big FPGA itself, they're just level shifters.
Yep.
And an interesting thing I discovered on the way to the forum, if you neglect to feed the low voltage reference to these level shifters, they assume you want 5 volts.
Oh,
Yeah. Fortunately, I didn't have my my dev kit powered up when I discovered that. It hasn't done any damage to it that I found, but
So
that could have
far.
been hideously expensive because those dev kit boards do not come cheap. Everybody who's got a Mister with a DA10 Nano, you know, you're looking at $250, pounds, whatever, to obtain one of those if you can find one. I elected to dodge that and go with the AMD kit for my dev kit. Oh man, Frederick, you are so lucky. I wish I could, but I shan't. But it has led me to the AMD range, which is really nice. Unfortunately, they've just announced they're killing off all of the older chips. Because I was thinking, yeah, I can use the same tool chain. It doesn't matter what I target. It's all in the same tool chain. I don't have to change the logic. I just have to let the software do its job when I compile it. And unfortunately, that's no longer the case. Fortunately, the Spartan 6, which is their small FPGA, I say small, it's 144 pins. It has a lot of I/O, far more than I need. And in fact, you could probably squeeze the entire Dragon 32 logic into that one FPGA. On the other hand, it's actually quite cheap, and it's not full grid array, because one of the other things that came out of all of this is your average PCB prototype fabricator can't manage the tolerances you need BGA. It won't work, and better still, they don't do blind and buried vias. So unless you do special orders, and some of them will, they will do it. They will do special orders at your cost. You can't just go in there and upload some Gerbers and say, make this for me. They will reject it.
I have
Which
a
is
couple more
painful.
questions. Couple more
Yeah,
questions.
go ahead, because
Okay, so
I'm burning time.
Carrie Shug. Yeah, I know we're right at an hour, but I have the next slot, so this is very nice. So let's just keep going. Carrie Shug says, talking about the Dragon 200s.
Yeah.
Do you know how many there are, and have anybody been restored? Is anybody doing anything with them?
In terms of how many there are, I'm the wrong person to ask. I don't know, but this is edging into Dragon 200 territory. Frankly, the differences between what we're doing just on raw spec, this is pretty much the same thing. Have they been restored? I honestly don't know.
You don't know. That's fine.
I've been so heads down on this, focused on Dragon 32 and 64, that I didn't really go into the depths of what that is. The Dragon Pro really interested me, and I'm sure Sixy's got stories to tell around that.
I'm trying to talk him into coming on here.
Yep. And the interesting is, as was demonstrated last weekend with the CoCo Deluxe,
Yes.
what we've actually got is convergent design.
Mhm.
The differences in spec are actually quite small. There is some differences, and as a friend of mine would say, the devil is in the detail. But actually creating the Rev 4 board, which is what I just showed before this, and making it compatible with the Deluxe CoCo actually isn't that hard. The SAMX4 makes it possible. You can do either or. So rather like loading different cores on the Mister, you can change the core on the SAMX4, and it completely changes which machine you're talking about. The only problem I haven't solved is the keyboard interface. But my new keyboards are switchable. So you can choose whether you're outputting the CoCo or the Dragon alignment of the pins. keeping in mind that the actual pins on the main board stay the same. All it's doing is shuffling which pins go to which PIA bit.
Yeah, years ago, the guy who did Flagenbird, I was asking him about the difference between the CoCo and Dragon, and he gave me a breakdown of the retokenized basic, of course, the entry points in the ROM, various stuff, the keyboard matrix, and then, of course, there was one other thing. But anyway, I have a list of the 3 items, so I was pleased to see how easy it is. If you can take some precautions, you can actually target both systems pretty easily. Oh, I do have one other question. Rocky Hill, Pedro Pena. He said, for you, at megahertz speeds, have you considered using resistor voltage dividers for level shifting? Sometimes you can get away with it if the input resistances are high enough.
Yeah, I have thought about it. The difficulty starts to come in with making space for them when you're talking about lots of lines. If it was just 1 or 2, I probably would have done it. And it probably would have been sufficient, because despite the fact I'm using bidirectional level shifters, I'm actually got them all set permanently to one way.
Yeah, the TI has some level shifters I've messed with that are pretty compact when you get the SOIC, I guess, packages. So you can get, and they're bidirectional.
Yeah, which is, of course, another funny story, as I discovered, is that not all SOIC packages are the same. They come in different widths. And
standards, there's so many to choose from.
So I don't know if I'm going to stop sharing this slides. The only sort of stuff left is the funny lessons learned bit at the end. If I come back to sharing and try and squeeze this in, you may notice that the pins on these level shifters are not as they should be. This took some interesting manipulation. Basically, the pins are folded underneath because I used the wrong footprint. And the interesting side effect of that is they don't always line up quite properly. So every single one of those pins had to be manually adjusted to sit on the pad after you soldered it down and manipulated. Fortunately, the probes on a Cisco are just fine enough to do it. So you heat it up, manipulate it. Does it work? No. Try again. And eventually, after spending about an hour on each chip, you get what you need. Let's just say I won't be doing that again. I will be not just double checking.
Triple yes.
Yeah, you got it. Just keep going.
Isn't that carpenter adage about measure twice, cut once, or maybe in this case, measure thrice?
They are so optimistic, those guys.
Right.
Yeah. So, I mean, a few things I've learned out of this, though, just to finish this off. You can never have enough test points. If you're going to make your own PCBs, put test points in. And better still, get a nice big hook for your ground. Fortunately, the Dragon, and I assume the CoCos, where you've got the 6-pin reset. One of those hooks on the top is absolutely brilliant for hooking your oscilloscope probes on and getting a good solid ground, because actually that is where the ground comes in basically for most of the board. What else? Ground planes. Yeah, make sure your ground planes are as good as you can make them. If you can have a whole 100% layer of your board as ground, do it, because it makes such a difference to the quality of the signals. It really is important. One of the boards I have here has a load of copper tape on the bottom, neatly soldered to the ground pins on the RAM, to get rid of some noise on the data lines that was otherwise killing it. Yeah, I wouldn't go into that one too much. What else? Auto routing. It's bad. It's great for small project, but just auto routing is bad.
It don't use really the one that comes with it. No.
The flip side of this is manual routing is hard.
It's fun.
It's fun, absolutely, but
Tedious.
it's hard. And modern EDA, KiCad 8 came out yesterday, day before, as a huge step change on 7, and just years ahead of 6 in terms of just how good it is, how easy it makes it. But it's not idiot proof. If you tell it to do something wrong, it will do it.
Wrong.
Yeah.
And yeah, absolutely. It does what you tell it to do. Yes, you've got all the design rule checks, and they are getting far more robust. But it doesn't tell you you've got a dead short. You know, it'll tell you if you haven't got 2 pins connected. It will tell you if you've got wires crossed, but it won't tell you if your ground fill is causing a dead short, for instance. Or that you've just managed to name things wrong, and you have somehow managed to cross those power lines over. And yeah, you can ask me about that later. As I started, this PCB fabrication is so cheap these days. For small boards, I made up a small board for someone, having tweaked it, shrunk it, improved it, and compared with buying 5 from your famous PCB fabricator that advertises everywhere, I could get 100 of those. The same circuit, but 100 for the same price, just by shrinking it. And obviously slightly cheaper manufacturing, which is real eye-opener. Yeah, choose your suppliers carefully. What else? Replicating boards just takes patience. Building them takes money, lots of money. And let's not talk about populating them.
So how much did you spend on just the circuit board designs?
So you have to bear with me a moment, because I didn't actually have this to hand and ready. But if I go to my order book and I look at the fabrication, so the total cost of PCBs so far, and that's getting to the second revision of the Rev 3 board, which is the 256K board without SMD, has cost me £400. Now, in the grand scheme of things, you know, I could have gone away and I could have somehow managed to get a CoCo 3 for the same money it's cost me to fabricate all of those boards. This
Remember,
has
the
been
prototypes always cost way more. Now you can make a million of them.
Yeah, I mean, I managed to sell enough boards before I started doing the Rev 3 ones to basically cover nearly all of the fabrication costs for the boards. It came close. Obviously, you start doing more boards, it gets expensive again, and the cost of fabrication has actually shot up this year. There's about a 20% spike in the cost of fabricating the boards.
Hey, Julian?
Yeah.
Brian Wiesler is also on the online audience. He's the one that got the deluxe CoCo that came from Robert Kilgus, that has the alpha ROMs or maybe beta ROMs in it. Anyway, he just basically says he'd like to talk about adding some deluxe CoCo comparisons and possibly adding some of its features.
Yeah.
Anyway, so yeah.
I'm discussing it with Pedro on the Discord. We're actually looking at going, you know, what can we do to align these closer? The big changes is things like the color phase adjustment. And using 16K pages instead of 32, which is what I've got at the moment. But I've got enough space free in the CPLD now that I've ditched all the RAS-CAS stuff. That actually that shouldn't be so bad. And obviously there's more pins than needed. It's probably going to take a bit of assistance from 60, because he's made so many changes to it, funnily enough, with Pedro, in order to incorporate other versions, CoCos and Dragon, none of which I need. So most of it can just be stripped out. this is only going to be for one board. You don't have to accommodate boards that have only got 4K or 16K on them. You know, we can do away with all that and streamline it, cut it down, and we can do good things. The deluxe side of things really inspired it a bit. There you go. So
I'm impressed with all of you guys doing this, just, you know, taking, recreating what was there so we can have a replacement in case you're, I mean, there are people that have damaged boards that have all the components at work. So what do? You're dead. So now you got
absolutely,
a board you can get it working again, but then taking it further too.
Yeah, I fixed a board up early this year for a museum in the heart of Austria, the Dragon 64 board, which 60 supplied to me. And it's a case of just taking all of the components off, putting new components in where they needed. We had hoped we'd be able to fix it, but someone had worked on it previously and the board was warped. It was delaminating.
Non-temperature controlled iron.
No, I don't think it was so much that as the fact of they tried to do too much at once on one chip to try and get it out and rushed it. If they'd taken their time, let it cool off a bit in between, it probably wouldn't have done it. That said, there was evidence of burning. So they just went hot. And it absolutely wrecked that board. There was no way back. I did manage to fix most of it with bodge wires, but so many of the signals were floating and picking up inductance because they were moving. Every time you touched the board, it was all over the place. Really nasty, really nasty. One last thing to remember, guys: solder mask color math. That's my final comment.
Why?
It actually, well, other than some look better than others, green solder mask is more durable. It stands up to rework far better than, say, blue. And if you go with black, you can actually have trouble seeing where you're soldering because it obscures stuff unless you've got the lighting just right. Purple looks fantastic. This is the Alpha 2 of the Rev 3 board, and it looks majestic. It really does look good. There you go. That's me.
Okay. Do we have any
Congratulations.
further questions? By the way, we have a couple of the people that snuck on here. Frederick, of course, has asked some questions. Ron Delvaux, our Garage Ron, who's always got lots of things in the air, and Simon Jonason's been hanging out too, and he's a fellow Dane/Brit who lives in Denmark. Did I say, Simon? No, go ahead.
Pardon?
Oh, just acknowledging you're here, Simon. Glad you could join us.
Welcome.
So, any other comments from the viewers?
I do have a question concerning your. You said you switched from 32K page to 16. Does that cause any compatibility problems, or
well,
is that something that's supported natively?
I planned on using the 32K paging because that's what Stuart Orchard did, and I just hijacked his design and incorporated it. So he did the VHDL for his PLA or GAL, and I just thought, yeah, I'll use that. As it happens, in the intervening time, I've taught myself how to do Verilog and picked up VHDL along the way. Why I didn't do it earlier, I don't know. It was so simple, intuitive almost. But then again, I used to do Step 7 logic design. And you know, if you can do that, you can do anything. But that's the only reason it's using 32K. I've talked to Mike Miller about it a lot around MMUs and coming up with better schemes for paging and what would be really good in the light of things like OS 9 and making it do what it needs to do. There isn't a final solution there, but if you're going to do Deluxe CoCo, you need to use 16K pages. Otherwise, you're inherently incompatible. So 16K, I can do that. I can do different schemes depending on what VHDL we put in the SEMX4.
Carrie Shug had another question. Did you ever go back and get our original out of storage?
I assume you mean your original, not our.
I think
yes, yeah, I did. Yeah, I broke my original Dragon 32 out of storage. Actually, it's been out a couple of times before I even started this. To be fair, it works. I had previously fixed it. I managed to melt the power switch on it. And incidentally, I found out why they tended to melt on Dragon 32s. It's because it's a RS component, and it's intended to work at 120 volts, not 240.
Oops.
Now, that's less current. However, the extra voltage means it arcs a bit as you move it around.
Yeah,
And over time, it does damage. Who would have thought?
Just get the 220 volts comparable one, swap it in, you're good.
That's it. There aren't all of those big power switches, the piano switches, they're either 30 volts or the 120. I spent some time just a couple of weeks ago trying to find some for somebody else and got really frustrated with it. My Dragon 64, yeah, I also dug that out, and that just works. A few small tweaks, clean off the fur that's grown on the potentiometers. Still don't know what that is. It's obviously chemical reaction there somewhere. What, I don't know, considering their carbon trace. But never mind, looks like aluminium oxidation. Okay. No, they definitely work. And I think I saw a question pop up from Ron around the case. Before I forget.
Yeah, do you have any case solution? Like, have you thought about, some of these newer machines now have smaller footprints and don't have to be looking retro, I guess. Have you thought of that?
Yeah, I have. Funnily enough, I've thought long and hard on this. The challenge is, do you want a Dragon? Do you want it to look like a Dragon? Because the case design, remarkably good, considering it was trying to rip off the BBC design, which won awards. Very well recognized. A bit of Apple II in there, make it big, make it chunky, really practical for sticking your little 14-inch color TV on top of it, or stacking drives on it and your TV, because it's a really robust design as well. They didn't actually skimp on the case design. Ironically, it's nearly all empty space. There's about 2 inches of clearance between the boards and the top of the case. What they were going to do with it, I have no idea. Although the Dragon Pro, I mean, they stuck twin drives in there, angled in, but there's still loads of space in there. You could easily compress it up. You could incorporate the power board. You can shift things around. As you saw, I've got loads and loads of empty space now. You don't need all of the big transformers in there. Small switch power supply taking up one corner of the board, not a problem. You could really compress that up. You can make a smaller design. The difficulty is the depth of the board. Unless you go the CoCo route and put all of the interfaces at the back, the depth of the board is limited by the fact that you've got reset, you've got 2 joystick ports, you've got the tape port, you've got a serial port and a parallel port all down one side, and that is literally the full length of the board. So you've got to do some serious redesigning, reconfiguring, moving things around. If you want to put them at the back, you can't have the separate power board that the Dragon has that sits behind it, because it blocks everything. Now, you could stack them, you could have a vertical arrangement and still achieve it. And that's quite possible. All of these things, sat there and going, okay, let's throw this out. Let's forget the original case. What can we do? So my white keyboard here is fairly thin compared with the height that you need for the original case, which basically goes to about there. You have to make the keyboard that deep in order for the keys to project out of the case. You don't have to do that. You know, that's just the case limiting it. So if you change your constraint, if you move the variables, then yeah, we can do all of these things. But I don't have a 3D printer. I don't want a 3D printer. I may sound mad because despite the fact I would love to be doing that, what I don't
It's a
want
learning
to do
curve.
it's a learning curve. What I don't want to do is throw away more space because for everybody who lives in the UK, space in houses is a problem. Not as bad as it is in some countries, but in the UK, houses are premium.
Most of us live in the US and Canada here. We have lots of space.
Yeah, and we're all jealous.
Yeah, as you should be.
Yeah. So, you know, just saying, you know what, I'll get a 3D printer in. Unless you're going to say, actually, I'm going to sacrifice my garage. And in case anybody else doesn't realize, garages in the UK are small. I have a car in my garage, and that's all you get in there. In fact, you can barely open the door to get out of the car once it's in the garage. You would be better off pushing the car into the garage. Fortunately, it's a soft box. You could always climb out the top, but it is not convenient in any shape.
Vehicles used to be smaller too. You can tell by our older highways here that are narrower.
Yeah, yeah.
Like
you wouldn't
the highways
want to be driving
wings.
Yeah, you wouldn't want to be driving a Humvee in the UK.
Nope.
But then again, I used to have a Ford Explorer, and for everybody who loves such things, it was actually one of the best cars I've ever had. Right up until the fuel pump died. Yeah, let's not go there.
Kerry had a question. He said, aren't there maker facilities or libraries where you can get time
There
on a 3D printer?
There are, but if you want to print a case, you've got to find something with a 600 by 600 bed. Those are few and far between.
Mm-hmm.
And the time it takes to get them printed means you are going to be block booking that probably for a couple of days.
Yeah.
And that's just to do one half of the shelf.
Yep.
You're not going to be popular. It took a while to get the keyframe that I designed printed. Even just that, which is what it's 1.5 mil thick, width of the keyboard. That took ages on one of those. Basically, because makerspaces don't necessarily have the latest, greatest high-speed feed, and if you want accuracy, you need to slow it down a little bit. And it can be done. We've got a couple of makerspaces near where I live, but the next hurdle is you've got to do all the 3D modeling.
You know, it seems to me that everybody fights whether or not to stay retro, and doesn't common sense sometimes tell you that you should just make a whatever's available case, and then make your keyboard modern, like maybe even have you know, like mice or wireless. I mean, you could do that and still have a retro look and feel, and you can put a sticker on the case that looks like this, and you know, or even emboss a retro look to the new case. But
yeah, so we're actually one of the other things I've got here. So courtesy of the same friend who's done the GoTech and drive controller in one piece, he designed me a PS2 keyboard adapter. So actually, I could just plug in an external keyboard. It would look wrong, but then again, I could make my own PS2 keyboard. You know, it's not the height of technology, and it's an interesting direction because again, it removes more constraints. And the keyboard design I've got is USB. all I've done is you throw a 9-pound Raspberry Pi Pico in there.
Well,
it does all of that for you.
We've kind of done that with the CoCo Pi. We have I have a case. The Pi's inside. The keyboard works off USB, and it's the original keyboard that's converted. And it's amazing. It looks just like, but it can go on Windows with it.
Yeah,
it can go on, on
as I said, with my keyboard, I could do that with my PC, but doing it the other way and incorporating a USB hub into a Dragon 32 presents a different kind of problem. Again, it can all be done. In fact, USB is easier with the likes of the RP2040, although you've still got level shift problems.
Well, you can pretty much do whatever you can think, right?
Yeah, absolutely. For the sake of what's 14 bits, I think it is, for the keyboard. You could do all of this, and you're no longer limited by so many of the things that we had 40 years ago in terms of design, because the tools are so much better. The parts that we wish to use are so more refined. Although, I mean, nothing wrong with 74LS logic chips, but they're big, they're chunky. Fine if you like your dip chips, but if you want to create small, cheap electronics, you need to shrink the whole package, and you can do that now. And
and there's
one
also
day soon they'll get
availability
rid of it.
issues.
But yeah, and availability, and that's actually the biggest issue with all of this. Something I'm really, really aware of is that a lot of the stuff I'm designing with and speccing,
It's on the trailing end.
some of it's on the tailing end, and it's actually that point about the BGA and not being able to get the PCB fabricators to do it readily. A lot of the modern chips only come in BGA because they integrate more and more, and we're getting to a point where that technology is exceeding what we can achieve as hobbyists. That scares me.
The problem with BGA ball grid array is that to do it properly, you have to use basically X-ray inspection to make sure everything's down. And so it makes it really tricky. I mean, it's like even where I work, we do electronics. We don't do anything with BGA.
Yeah, it's not fun. Fortunately, a friend of mine's world authority on X-rays and has all sorts of equipment that he shouldn't necessarily have. So
you got an in.
I've got an in, and funny enough, he's a Dragon 32 enthusiast.
Ooh, even better. Hey, do we have any more questions? I've seen a few more comments here. I'll throw them out here. Rocky Hill said he bought a budget 3D printer, and it's a love-hate relationship. Oh, Six, he's so jealous because you have a garage or a garage.
I've got a drive as well, and I apologize to so many people in the UK in that I am lucky in that I have a lot more space than people are used to. The caricature of a British 2 up 2 down house, or worse still, has been turned into a studio flat, and there's just no space there at all, is actually incredibly common. And for a lot of people, it's all you can afford. And I am incredibly privileged with where I am. More so where I grew up, which was by UK standards would count as a small mansion, but only for the space it had. But that's more to do with where I grew up rather than privilege or anything. But it would it would fit with the American dream quite nicely, except that it was a 500-year-old property. You don't find many of those in the States.
We don't have any of those. Well, maybe the Spanish missions in California, but any other questions? I think my restream says we've had 27, 25 people watching, and quite a few comments.
Yeah,
any other questions?
Small audience for me.
Yeah, it is. We usually get good replays. So before I did this, I kind of took this on this CoCo Virtual Fest because I started up this thing called CoCo Tech, which is kind of focusing on exactly stuff like this. And I'm surprised. I go back and look at the YouTube views, and I'll have 200, 250 replays. I only get 35, 40 people because I was doing them in the evenings here in the U.S. But the replays are important because people have to time shift. So I'm happy that people went and looked at it. So, and I'm sure we'll get a few on this as well.
Well, as my first YouTube attempt, I'll look forward to seeing just how well it goes.
Good. And hopefully we can do a few more as you get some updates. And also, if we can talk you into coming into like the CoCo Nation, we regularly feature people doing stuff like you do. We've had Rocky on before and Kieran. So if we can get you to come on and show off, you don't have to spend a lot of time. We can front load you. So it's, it's 11 a.m. my time. So it'd be 7 p.m. your time. We could front load it. So it'd be, in the evening for you for a short period of time. So.
Yeah, no,
anyway.
I'm happy to come on the show anytime you like.
Okay. Well,
preferably at the start rather than the end before.
Yes, we will do that.
It gets
especially
a little bit late. Yeah.
Like I said, this is special for me. I started at 6 a.m. this morning here to get you on. So anyway,
thank you.
Well, we're an hour and a half in, and this has been really good. So let me just wrap this up here. Basically, we're doing a few more of these today. I was going to do one right after Julian here, but I won't need to. I'm going to take a break for about 4.5 hours. Then we'll be doing Paul Fiscarelli, who's going to be talking about the grease weasel and imaging discs, basically. And that's going to be followed up by Brett Gordon, who's a CoCo guy who ported Fusix to the CoCo 3. He did the Plato terminal for the CoCo 3 from Thomas Cherry Holmes code, and has a few other projects that I'm aware of that he wants to share. So it'll be fun with him. And then Thomas Shanks will be after that. These are basically hour, by the way, so it'll be 4 hours in a row. Thomas Shanks is going to be doing his new Pico project, which is a Pico, Raspberry Pi Pico hooked up to the CoCo for basically internet wireless activity. And I don't know what else he has in mind, but he's a good friend of William Strickland, who's written the boot routines for Rick Euland's CoCo IO to boot Nitrous 9 version 3 off of, or I guess version 1. Sorry, version 1. I don't think he's got version 2 working yet. Basically, Nitrous 9 to get it to boot off of a network server and onto a CoCo. And then Rick has the final one after that. So the last 2 hours are going to be all networking stuff. Anyway, give me a break here for 4.5 hours, and then we'll be doing this again for 4 more hours. Anyway, thank you very much, Julian, for being here, and we'll hopefully get you on the CoCo Nation at some point or on CoCo Tech. I'm flexible for doing a CoCo Tech at like this time my morning, which would be your early afternoon, so we can get stuff like this on because it's all good. Any final comments?
Thank you for having me.
Oh, so glad. It's like, I do my thing, but, and I can do this somewhat. I'm still new at this streaming thing. But, there's so many projects out there. It's just like, let's shine the light on them. It's like when we started CoCo Talk, the CoCo Nation 6 years ago, we're coming up on the end of our 6th year now. Part of it was like, there's all these projects out there. If you just like shine the light on us, you can post stuff on Facebook. But if we can get you on, you can talk about something for a half hour and show your stuff. It's amazing. I was telling Julian earlier, yesterday we covered on the CoCo Nation. There's a guy, I can't remember his name offhand. He made a little board for the Dragon 32. It's a little power board, so it uses a single 12-volt source, regulated source. Ant. Anyway, Mikey Furman, who did the Pi Drive wire, he said there were 6 units for sale when we started our story. By the time we were done, they're all gone. It's like, that's the power of media.
I've got 3 boards left.
3 boards left. That means send. Yes. Oh, that's right. Give me your link for your eBay site and we'll get that posted. So yes, 3 boards. Please help fund his development. Buy boards. Anyway, I'm going to call it good. We're going to push the button here, as we say. Let's see. A few comments here from various people, but nothing specifically directed to you. So I'm going to call it good. Bye, y'all. See you in a few hours.
Okay.